Hello, everyone. A little housekeeping note. We'll be starting this session soon, and we'll be recording this for posterity so you are all aware. Any questions that were not addressed will be answered by email if able. This presentation eventually will be available for on-demand viewing on the Wiley Science Solutions website at sciencesolutions.wiley.com in the webinar section. Good day. My name is Mark Lucchetti, Field Marketing Manager with Wiley Science Solutions. Welcome to today's webinar entitled Introduction to Wiley Surface-to-Spectral Analysis, Go from Microscopy to Spectral Analysis in a Single Workflow. It is my pleasure today to introduce you to our speaker for this informative session, Dr. Leanne Ergen of Wiley Science Solutions. Dr. Ergen is an associate editor for Wiley Science Solutions, for which she helps to create tools for spectroscopy, structural and scientific standard reference data, and helps create innovative software applications. Leanna completed her PhD in clinical bioanalytical chemistry from Cleveland State University. We are excited to have Dr. Ergen present us today her webinar entitled Introduction to Wiley Surface-to-Spectral Analysis, Go from Microscopy to Spectral Analysis in a Single Workflow. We encourage the audience to submit questions, which will be addressed at the end of the session. With that, I'll turn the stage over to Dr. Ergen for her presentation. Take it away, Liana.
Thank you, Mark. Let's start with talking about what surface analysis is. So it's a method to analyze the chemical structure of the surface of a sample. Surface analysis is important because the characteristics of solid surfaces depend on the chemical structure of the surface. The surface of the sample is what interacts with the surroundings. So there are a lot of characteristics of that surface that are often of interest, such as chemical activity, adhesion, wetness, electrical properties, optical properties, corrosion resistance, friction, or biocompatibility. So for example, Raman microscopy will penetrate less than 12 micrometers below the surface of a sample. So anything beyond that surface will not be measured. So for all microscopy, the penetration limit depends on the specific technique and the quality of the specific instrument. So what is Wiley Surface-to-Spectral Analysis? This new software provides a comprehensive, powerful solution to process, combine, and analyze images and data from various microscopies, all within a single workflow. So users can even take their analysis a step further by sending spectra to Wiley's KnowItAll software to search against spectral libraries for further investigation. So what can you do with this software? This software is a comprehensive solution that consolidates your workflow. So it would enable you to perform spectral processing and analysis, such as enabling you to visualize and analyze spectral series and hyperspectral images, create spectral maps from selected bands. Processing methods include baseline corrections, filtering, peak fitting. Next up, you could also do spectral map and image processing, such as color mixing of layers, adjust image noise, adjust transparency between layers. You can perform correlative analysis, so you can associate images from a single or multiple techniques. You can visualize 2D compositional data in 3 dimensions. So the software enables you to create 3D visualizations of chemical maps by co-localization with microscopy images or topography data. The software also has smooth integration to our existing KnowItAll software for spectral library searching. The user would need to have licenses to both softwares in that case, though. So what techniques are supported? This slide lists the techniques that are supported. For specific file formats, you can find the most current list of supported file formats on our website. This is a vendor-neutral solution, so we support a lot of different file formats. But the techniques supported include these that are listed: Raman, TERS, IR, nano-IR, fluorescence, photoluminescence, cathode luminescence, EDX, EDS, and XPS. with add-ons to the software for SEM, SPM, particle analysis, and profilometry. Now, that last slide had a lot of acronyms, so let me give you some very brief definitions of some of these techniques, just in case you aren't familiar with all of them. But Raman, IR, UV-Vis, those are pretty common techniques. TERS stands for Tip Enhanced Raman Spectroscopy, TERS. It's a technique that allows for nanoscale resolution of Raman spectroscopy, and TERS imaging performed on an AFM coupled to Raman. So nano-IR, also called nanoscale IR, allows for nanoscale resolution of IR spectroscopy. Fluorescence, photoluminescence, and cathode luminescence, these are imaging techniques that measure different types of luminescence. Cathode luminescence can be coupled to an SEM. EDX, EDS, these acronyms are interchangeable. They would stand for Energy Dispersive X-ray Spectroscopy. This is an X-ray technique that produces characteristic peaks in a spectrum for certain elements. It's commonly coupled with SEM or TEM to demonstrate elemental distribution over an image. And finally, XRF for X-ray fluorescence spectroscopy. It's an X-ray technique that produces characteristic peaks in a spectrum for certain elements. It's used to identify and quantify metals in a sample. So next, I'd like to perform a demonstration of the software. So let's talk about the user interface a bit first. This main window in the middle is called the document space. It looks a bit like an Office document. This is a completed analysis that I've already performed, but it's showing you the history of the analysis and a report all in one. So this document is created during the analysis, and there's no generating a report at the end. Over on the right side in the workflow, there's a history of the operations performed. Some terminology. The term studiables is used to refer to a data set. So if you see load a studyable at the top left, that enables you to open a data set. The operators tab is where you can find a list of ways to modify the data. And studies is what the software refers to for the individual windows within the report. Now, there is a tab at the top that's very helpful and also very interesting. So right now I've selected a hyperspectral image view. And when this is selected, a new tab appears at the top, hyperspectral image view, with a list of operations that can be performed on a hyperspectral image. If I click some other window, this is a grid view for the sample, and I have a grid view tab with operations that can be performed on it. So depending on what is in focus, it's giving me options of what can be performed for that particular window. There's also a help tab at the top that can direct you to a lot of helpful information. But I would like to open a new document and show you a brief demonstration working on a data set from scratch. So studiables, load a studyable. I'm going to be opening a Raman hyperspectral image for a sample of graphene. Now, right now the data is open. For whichever pixel location I click on, a spectrum corresponding to that pixel location is displayed at the bottom. So let's say we want to clean up the baseline. I can go to Operators and correct the baseline. There are 4 different algorithms to choose from. One that's currently selected is lower morphological envelope. There's a setting for this particular algorithm, which is element width. I can drag this or type a wave number range down here for how fine or smooth I want the background correction to be. But when I click OK, a new window pops up, and this is The new one that appeared on the right is the new version of the data set in which the background correction algorithm has been applied to each and every spectrum. But let's clean up the data a little bit more. So this is a Raman hyperspectral image. So each and every pixel has a Raman spectrum associated with it. And Raman spectroscopy is prone to getting cosmic spikes. So there's a remove spikes algorithm. If you click use height and width criteria, there are some default values here, but this is basically defining criteria for a cosmic spike that you would want to have removed. You can also use selection zones. So in this mode, you can drag this window to a certain region within the spectrum, and any of the cosmic spikes within this window will be removed when you click OK. So next thing I want to show you is correlation. So I'm going to operators again and use spectral bands. So this is a Raman hyperspectral image. And in Raman spectroscopy, peak locations correlate to certain functional groups. There's a preview here, but it's only showing one wavelength at a time. This is the very first wavelength. I can drag this to find a wavelength for the display that's a bit more useful to look at. Something in here. This green dot, I can drag it, and the bottom is going to display the spectrum for this pixel location. But I have a peak here that's pretty predominant, and I am going to drag the edges of this box to make it pretty tight around this peak. And over at the right, I see an image. And right now that's showing pixel locations where the maximum amplitude is this peak. I could also do full width at half max, area, max position, but right now I think max amplitude is a good view. It's showing me which pixel locations have a maximum amplitude of this peak location. But you know, some other spectra within this data set might have different peaks associated with it. So we can drag this dot around, and I can see down here towards the bottom, this peak is shifted a little bit to the left. If I want a second peak correlation, I can double click to open a new window, and I can drag this and resize it. And I now have a second tab that has shown up over here. Going to max amplitude again, I can see that down here towards the bottom, these pixels in green have a maximum amplitude at this location. So I can go back and forth between either view. But when I click OK, that window also appears. Now, let's say you've gotten this far within your analysis, and you think, oh, I wish I would have done something differently with this baseline correction algorithm. You do not need to undo all of these operations just to redo the baseline correction and then redo everything after it. Over in the workflow, I can right-click on the operation, any of the operations, and recall the operator. This is bringing up the window for the baseline correction algorithm. I can change details about the algorithm. Once I make the desired changes, I click OK. That's actually going to carry that change through everything that's happened after it. So also by right-clicking, I can deactivate and then subsequently reactivate an operator if I just want to see what the analysis looks like without it. I can completely delete the operator. I can insert an operator before, so you can see the list of operators, same as the tab at the top. And this is extremely helpful if you wish you had done something differently about your analysis. But let's go down here to this hyperspectral image view and select any pixel location. There is a link in this software to KnowItAll if you have license to both Wiley Surface-to-Spectral Analysis and Wiley's KnowItAll on the same computer. So with this window selected and with a certain pixel location selected, I can transfer this spectrum to KnowItAll, and it will perform a spectral search within the library. So I need to tell it what technique was used. So this was Raman. And once I click that, it is automatically opening KnowItAll on this computer and performing a spectral search. We can see that the top hit with a 96.27 hit score, where perfect score is 100, is graphite. And that makes perfect sense because this is a hyperspectral image of graphene. So this concludes our demonstration on the Wiley Surface-to-Spectral Analysis. If you have any questions, please visit the Wiley Science Solutions website at sciencesolutions.wiley.com. This is the
That was a wonderful webinar, Liana. Thank you everybody for your attendance today. We've reached the end of the presentation. Thank you, Dr. Aragon, for your time and expertise to present us your talk on Introduction to Surface-to-Spectral Analysis. We'd like to now open the session to some questions from our attendees, which, if you can please type in the questions toolbar, that would be great. Dr. Aragon will also be joined today by our product manager, Dr. Michelle D'Souza. We have coming in. How about this first one? This is a great product. Is there a trial available to be able to test out?
Yes, there is a free trial that's good for 3 days. And in order to get it, you would need to go to our website, sciencesolutions.wiley.com, and click on Learn More. You can be put into contact with someone who can help you get started with the free trial.
Excellent. Thank you, Liana. All right, here's another one. Can you tell me more about some of the add-ons that are used?
Certainly. Yeah, so there are a number of add-ons to the software to get access to additional features. There's an SPM add-on for scanning probe microscopy or force microscopy. So this would include atomic force microscopy and scanning tunneling microscopy. Another add-on is for particle analysis. This is a toolkit to analyze images containing particle shapes. There is a chemical cubes add-on. This enables the user to do 3D multi-channel cube generation to depict 2D data that way. There is an SEM add-on for scanning electron microscopy. There's also a profiler extension add-on for profilometry and surface topography. And if you have KnowItAll software and libraries, which is standalone software, not technically an add-on, in addition to surface-to-spectral analysis, you can search specific spectra against our IR Raman or UV-Vis spectral libraries.
Great. Thank you, Liana. So just a follow-up question to that, someone asks, are there add-ons also available in the free trial?
Yes.
Great. Okay. Here's one. Would this software be suitable for a school in conjunction with KnowItAll campus-wide solutions? Great question.
Yes, it would be. And I do think it would be an excellent addition to maybe a core microscopy facility on campus that has campus-wide solutions. It would also be a great way of leveraging the investment in the high-end microscopy equipment at the core facility. And a lot of times the microscopy equipment has like older, outdated, buggy software. So this would, I think, be a big improvement.
Excellent. Thank you. All right, here's another one. What languages are available in the software interface for this new product?
There are 11 languages. 4 help document languages. Let me pull up the list. So software and help pages are English, French, German, Japanese. The software, in addition to those 4 languages, is also in Spanish, Italian, Chinese, Korean, Brazilian, Portuguese, Polish, and Russian.
Wow, that is a great variety for folks to be able to utilize. Okay, let's see what else we have. How about this one? How does this work with KnowItAll exactly?
So if surface-to-spectral analysis software detects KnowItAll software on the same computer, it will automatically display the KnowItAll wizard hat button. And when you click that button, it allows you to send the spectrum that's in focus to KnowItAll. Once in KnowItAll, it automatically searches that spectrum against any databases that you have licensed within KnowItAll to search for a spectral match.
Great. Thank you again, Liana. All right, have a few more coming in. How about this one? That's why would we need to use KnowItAll specifically with this software product?
So KnowItAll is a tool for spectral comparison and analysis. It has a long history of providing accurate and fast spectral library searches and is used worldwide across a wide range of application areas. So you'd use KnowItAll in conjunction with surface-to-spectral analysis if you want to be able to search for specific spectra against a library database of spectra.
Thank you. Some other good ones coming in here. Here's a good compatibility question. Can I run Surface to Spectra on a Linux system or a Mac?
It runs on Microsoft Windows at this point in time.
Thank you for that clarification, Dr. Liana. All right, we have some time for a few more. Will this software be able to analyze FTIR spectrum?
No, right now just ramen.
No, it should be IR, Raman, UV Vis
Okay.
are the types of spectra supported.
Great, thank you for that clarification there. Let's see, a few more here. Are you planning to include the Raman-Renishaw file format as one of the supported versions?
It's already supported by KnowItAll.
Yeah, on our website at sciencesolutions.wiley.com, if you look for the tab for this surface-to-spectral analysis software, you can find a list of all the supported file types. It's quite an extensive list. I can't list all of them off the top of my head, so I'd recommend looking there.
Great, thank you both. Here's another one. After baseline correction, new peaks appeared, which were not very prominent in the first place prior to the correction. Can you expound a little bit more on that, Liana?
Yeah, I think the display at the bottom, if nothing is selected, is some sort of weighted average or composite. So when baseline correction is performed, it can just sometimes make certain peaks more predominant overall, but it would be a matter of figuring out which pixel locations within the hyperspectral image those peaks came from. They would have been there before. It just baseline correction changed the average display.
Thank you, Liana. We have a little bit more time here. Let's see. How, and this is a pretty specific question, how is this applicable for botanical materials?
So
Oh,
the
go ahead.
exact sample type shouldn't matter. If you are hoping to search a spectrum against our spectral libraries within KnowItAll, that's where it would come into play, depending on which spectral libraries you have access to and what is in those spectral libraries. Michelle, you might know a bit more about the specific spectral
Yeah.
libraries within KnowItAll.
Yeah, so if you found our library doesn't cover your area, you could create libraries of your own and then as you're collecting botanic materials, and then you can search against your library that way. So it's comprehensive.
Great. Thank you both for those clarifications. Let's see, might have time for one more question. This is a specific question. Can it be used with XPS mapping data from a thermo instrument? That may
I
be.
believe so, as long as you have a file type that is compatible. And to see the list of all of the file types we support, you can go to our website, sciencesolutions.wiley.com, and there is a list of supported file types displayed.
Excellent. Well, we're almost at time here. That was a great presentation. I think we've reached the end of our time today for questions. I'd like to thank our associate editor, Dr. Liana Aragon, and Dr. Michelle D'Souza of Wiley Science Solutions for taking the time to present us our talk on Introduction to Surface-to-Spectral Analysis. Any questions that were not addressed will be answered by email if able. This presentation eventually will be available for on-demand viewing on the Wiley Science Solutions website at sciencesolutions.wiley.com in the webinar section. Thank you very much for attending and enjoy the rest of your day.